All right, the internet. This is a video that I actually tried to record not too long ago, and yeah, it didn't go so well. I came out all over game, so I ended up deciding to redo it, so hopefully this take will be better and more usable. Anyway, so as promised in my last video, which was all about Skyrim and how to install Mod Organizer 2 as a first-class citizen, etc. and so forth, I promised you that I would show you the wonders of the find command. Now, I want to prefix this with, of course, I'm going to go into detail and I'm going to talk about a lot of the little nuances of it. I'm going to show you guys a lot of little use cases for it, etc. and so forth. But if you are a very advanced user and you're very familiar with the find command, there's not a whole lot that I'm really going to cover here that can be gleaned from or inferenced from the man pages. So if you're looking for like some deep, dark secret to find and you're an expert user, you may come away disappointed. It's always very difficult to tread the line between the skill levels of my users, right? Because trying to cater to people like myself who are very advanced would be quite difficult if I'm also trying to target beginners. So I always try to tread that line somewhere in the middle there if I can help it. So this is going to start out a bit more beginner friendly, and it's going to go up in the difficulty rungs, I guess. Although really it's not that difficult. Syntactically, the find command is a bit off-putting. I would say would be probably the best word. It's intimidating, I think, and I, as a young Linux nerd, was intimidated by it. I saw commands like locate and where is and thought, wow, those are so easy to use, I'll just stick with those, right? I didn't understand how great find was until much later in my career, when I finally decided to buckle down and just learn the thing. And once I did, it really isn't that bad. Really, the most difficult thing about it is that it's just syntactically weird compared to other commands on Linux. So for an instance, like our ls command, right? Our ls command here, right? So that's our basic ls command, right? And it just lists the files in a directory. Now that might look funny to you. It looks like it just didn't do anything, and that's because on this particular system, the directory I happen to be in, there just isn't a lot there. So if I touch something, test.txt for instance, and I do an ls, you'll see that I have a test.txt in that particular directory. If I do a pwd, I'm just in my home directory. So this is a brand new system, basically. I mean, kind of. It's actually been around for a while, but I don't use it very much. It's a test system that, I basically clone this thing off and then run with it. So anyway, that's the ls command. And then I can add a flag to it, right? Or a switch, if you want to call it that. So you can do an attack A, and it will show you all of the items in the directory, if they're, regardless of whether or not they're hidden, right? So prefix dot files there are hidden files. If I do an ls attack al, you can see that it changes the command again. And so if you do, I think it's ls tac, or tac help maybe. Yeah, so that gives you a little help output. And as you can see here, right, you have all these switches. So you have the short switch, and then you have the long switch, right? So you have tac h is the short switch, and then you have tac human readable. Now I could use either or, right? So if I use tac h, it'll do the same thing as if I do tac human readable. What's the difference then? Well, ostensibly there is no difference. Really the difference is in the use cases, right? So if I'm just at the shell, I'm not going to want to, or at the terminal, right? I'm not going to want to type human readable every single time I do my ls command if I just want, the output to be prettier. Instead, I want to type the tac h because it's much shorter. So once I learn that tac h is for human readable, you can bet you can bet that I'm going to be using that tac h instead of tac human readable every time. So why then would you have this monstrosity? Well, typically speaking, you would use that in a Linux script. So if you were going to write a script that would make use of the ls command in some form or fashion, you would prefer to use the longer commands or the longer switches. And the reason why is it makes the script more human readable, right? Somebody can easily say, oh, well, they've obviously selected the human readable option to the ls command versus the tac h, which might be cryptic to somebody who didn't know. And so that's the point. But if we look at the find command, it is structurally much different, because you'll notice that all of the short switches here, right, they have tac h, and then you have tac human readable for the long switches. But find, on the other hand, is much different. So if we look at the man page for find, right? So let's take a look. See, you do have some short switches, but if you look down here, you can see we've got, you know, different parameters here, but they don't have tac, and there is no short version of them. So syntactically, it's just weird compared to the other commands. So that's part of the reason why I personally avoided it for a long time, because I don't tend to like commands that are syntactically strange compared to other ones that I'm used to, especially as a new Linux user. But I would implore you to overcome that fear, because the find command, despite its syntactic weirdness, is amazing and will give you superpowers. But I would also advise you to exercise some caution, because like any command that gives you superpowers, it can also turn you into a supervillain, because, you know, it can be highly destructive if you're not careful in how you use it. So we're going to talk about all that stuff and how to be safe with it, etc. and so forth. So let's start off simple. So the basic structure of the find command, right? So we have find, right? That's obvious. And then we have a path, and we can set that path to, usually you'll see people do a dot or a dot / right? Technically speaking, you don't actually need either of them here. But for the sake of argument, we'll stick with a dot for now, because the / in that case is completely superfluous. You don't really need it at all there. The dot is sufficient. And then you can do a tac name, right? Name. And then you can say, I want to find any file with the name test.txt, right? But that's oddly specific, so let's not do that. Instead, let's just do star.txt. Okay. Now, if you do not quote this, it's not going to work. The only time you can leave off the quotes is if you are doing an exact match, which is kind of not really what find is all about. So I would argue you should pretty much always quote whatever you're going to put after the name flag there. And then if I press enter, you can see I'm going to get every single file that comes back with that .txt extension. Now, you may have been expecting it to come back with test.txt and only test.txt, because that is the only file that's in that directory. But what you need to understand about find is that it is by default a recursive command, meaning that it's going to find everything from the directory that you're in all the way down by default. So I was able to locate basically files in any .txt file that is underneath my home directory anywhere. So that's a very important distinction to understand about the find command, is it can be overzealous, and that's fine, because that's what the find command is for, but just be aware that that's happening. Now, what I wanted to show you with this find command is if we go back here, we can actually remove this dot entirely. So anybody who's putting that dot there, you don't have to. The dot basically just means current directory, the directory that you're currently sitting in when you run the find command. But here's the thing, right? The find command makes an assumption. If you don't provide a path at all and you just do find tac name and then a, you know, star.txt or whatever, it's going to assume that you are in, that it wants you to use the dot there, basically. It's going to assume current directory per the man page, right? Now, double check that on your distro, because I'm not sure on other distros if that's different, but at least in Debian, that is the case, and you can see that written in the man page if you look. Anyway, moving on. So that is that, but let's say we want to touch another file, and let's do test.txt, right, like this, or better yet, we'll do this, text, txt, like that, right? So now, if I do my find command as it was before, you'll notice that we don't find that second file that I made, but you can see it is there, and it does end with the .txt file extension, but now we have that capital letter. So how do we make this case insensitive? Well, we can simply add an I in front of the word name. And you'll notice that's a pattern with all of the switches in find. So basically, if you stick an I in front of it, chances are it's going to make it case insensitive, if it makes sense for it to have that option for your particular flag there, right? So if it's expecting a number, obviously you're not going to have case insensitivity. If it's expecting like a different flag or a variable or something, then that's different, right? But if it's something that it expects like a text sort of deal, like name or path, then you can add that I in front and it will make it case insensitive. So you can see here now we're finding everything regardless of the case that it has. So that will allow you to broaden your find search basically to things that are insensitive to the case of the text. Now, typically I will always roll case insensitive. So you'll usually see me, if you're watching me, do stuff, I'll usually, if I use the find command, I'll use it with iname or iPath or whatever, because I prefer to have it insensitive at first, and then if I want to narrow the scope, I'll take the I off, but generally speaking, I roll insensitive. Okay, so we've talked about file names. Let's talk a bit about directories. Now, find is actually looking for objects on your file system, right? Now, I refer to them as objects, but really what I mean by that is any file. And any file is anything, effectively, any object, because everything on the Linux file system effectively is treated as though it's a file, right? Whatever that is. That's just the way it works. So even if it's a directory, you can think of it sort of like a file in a weird way, right? But basically, for people who can't wrap their heads around that for whatever reason, you can think of it as finding any object on your file system. So you can use it to find paths as well, or directories effectively. So let's say I want to look for, if I look at pwd, right? Oh, it's actually, sorry. Let's just pwd. Now you can see I'm in home Joe. Let's actually cd up to etc here. Okay. And in here you can see we've got lots of little directories, right? So let's say I want to find something that's only in that light httpd directory. Well, I could do my find command as I did before, right? Except instead of iname, I could use iPath. And then over here, I could do star httpd star, right? And you can see here, it's going to find everything with that that httpd directory in it. And you can ignore these arrows down here. They're just directories that my user does not have the permissions to look inside of. I could actually fix that by adding sudo at the front. And then simply doing that. And now it can look everywhere. Anyway, so at this point we have light HTTP, and you can see we can look in that directory. Now, of course, that doesn't really make a lot of sense. That was just for demonstration purposes, because yes, I could totally do, something like this. So find HTTP, or actually light. This. So yeah, I could totally do that, and then I could do, iname, or just name and do star.conf, like this, okay? And that will find all the conf files in light HTTPD. I showed you the path one because, what if there were multiple directories? So like, let's say I wanted to find all the files underneath the RC directories, right? You see all those RC directories here? So if I wanted to see if there were any files in there, I could do something like this. iPath, and then RC, and then star, and then quote. Right, and now it's going to show me anything that has RC somewhere in the path. Now, as you can see, that was obviously too broad because we have things like SRC here, right? So maybe we don't want to do that. Maybe we want to only have it start with RC. So we could do something like that. Now, that's obviously not working either, so let's take a look at what's going on here. Yeah, so the reason that's not working is because it doesn't technically start with RC. This is the full path. So basically what is happening is the path technically starts at root, so it'll start at /. So what you could do instead maybe is do, I think it'll accept regex, so we could probably do a D and then make it dot and then D. Let's see if that works. No, that didn't work. I'm not entirely sure. Maybe that's a bad example because that's going to be an overzealous one. We could do maybe... what one would be a good one? Maybe app armor, right? Yeah, that's a good one. D, right? We'll just leave it like that, and we'll do star. Oh, and we'll also do star on this side as well. Okay, so this is going to show me everything that has app armor anywhere in the path name, right? And so that is, that's basically what that does, is it allows you to narrow the scope of your search. Now, I can combine different ones too, so I can do iname as well, right? And then I can say I want to find only stuff that, you know, has the word lib in it, right? So if I do lib like that, star, right? So that's going to find any file with the name lib at the beginning of it. And you can see I've got libpam systemd there, right? And that's the only one it found. Okay, so that is how you would combine the two elements there. And you can see that I've got the i's in there, so it's case insensitive. So if there were a different file that had an uppercase letter in it anywhere, it would find it as well. So you can also search for things by ownership or by permissions, which is also cool. So if you want to find files, for instance, that have gone onto your system that are owned by a weird user, say you deleted a user and you want to clean up and make sure that all the files that that user owned anywhere on your system were deleted, or you found them and you could see if you needed to delete them or rehome them to somebody else. You could do find user. Now, of course, if you're going to delete the user, you might want to run this command before you delete them. Otherwise, you'll have to search for their GID or something, or their UID, not their actual username. But if we look for all files owned by Joe, now obviously that's going to be very far and few between because there's not going to be anything in Etsy that will be owned that way. But what we could do is we could look for all files owned by Joe anywhere on our file system, which is what I just did. And I'm going to go ahead and kill that, as I don't want it to actually complete. I don't care that much. But the / basically, if you're not familiar, just means the root file system. So if I look at my file system / right, you can see that's where you have Etsy and home and all that stuff. If you're not a Linux, initiate. So basically, I'm saying from the top of my system on down, find any file that is owned by the user Joe. Now, like user, you can also do group. So I can look for the group ownership of Joe as well. So any file that's owned by Joe. And then you can also do attack ls, which will long list them. And that will allow you to confirm that it is, in fact, finding files that are owned by Joe and then Joe as well. So that's pretty cool. And it gives you the whole path and everything. It's a really nice way of looking at the files that you're trying to find there. Okay, so we can also search by permission. And this is particularly effective if you have files that are, for instance, set up with the dreaded 777, right? If, by the way, full disclosure here, never use the command chmod 777. I'm going to do a video about chmod 777 at some point because I see a lot of people use that command. I'm going to tell you there is almost never any reason to use it. Stop doing it. There's almost no legitimate reason why you need to use that, and it's dangerous to use. It can break your system. It can cause your system to refuse to boot up. You could lose the ability to SSH into stuff. It has all kinds of nasty side effects if you do that to the wrong file, and if you do it to other files that don't have any negative impact on your system, seemingly, it does introduce security vulnerabilities to your system. It's not a good idea. So stop doing that. It's a knee-jerk reaction. Quit it. Moving on. Let's talk about perm. So we can also look for something with a permission level. Now we can either give this a symbolic permission level, or we can give it the octal permission representation. So what is the difference? Well, the octal representation is what I just said, 777, which actually would be 0777. So if I look on my system for this, right, and I look anywhere on my system, if this system is configured correctly, I should get no output. Now I'm going to get output with this command because there is a specific type of file that will, actually I'm going to leave the long list on so you can see what kind of file it is. There is a specific type of file that will always have 777 permissions. But anything other than that kind of file should never have 777 permissions. And you should never have to chmod that particular file type to 777, because if you do, well, it doesn't matter. It's always going to be that, and if you chmod it to something else, it's just going to go right back. So let me show you what it finds. So you can see it's finding a lot of stuff. Now, I don't know if you recall, but before, all of our files started with a dash here, right? And that's because they were regular files. The ones that start with an L like that, they are symlinks, and you can see what they point to over here, right? Symlinks will always be owned or always have the permission 777. So if I, in my home directory, well, I don't really need to go into symlinks and all that right now. Let's stick to just the find command for now, and I'll do a video about symlinks and chmod and permissions and all that stuff on a different deal. But anyway, for the purposes of this video, just know that symlinks are an exception to the rule. They're always going to have that 777 permission level, but all other files will never have that. Right, so let's take a look at the other way to write this out. So the 0 here is for special permissions, so like set UID, sticky bit, and set GUID. So it's usually going to be a 0, but you can make it a 1, a 4, or a 7, depending on a 1, 2, or a 4, or 7, or whatever combination, the octal representation and how it works. I'll go into more detail on that in a different video. But anyway, just to show you this as well, you can also do this. So this would be the symbolic representation. So if I wanted to find files that are read, write, and then maybe G read plus R, right? I could do that, and it'll find any file that has that permission level. You can see here it's got read, write, and then read. You can specifically tell it not a permission. So if I want to say not write, you can do a minus, and it will find every file that doesn't have that. So you can do that. You can do them together, and of course you can also add in the world permission or the anyone permission. So you can say any file that has plus R there as well. And it's going to find all of those files as well. So that is permissions. And we can also look for files by inode number. So inode number, what is that? Let's go back to the home directory, and let's ls this. So if we do an ls tac al, we can see, well, actually, let's leave off the A and we'll just stick with L. That'll make it easier to look at. And we'll clear the screen and do it again. Okay. So this is these two files here, right? And these are different files. So if I go here and I put an I, you can see I get this funny number at the beginning of my string here. So that number actually represents the inode number that the file is actually represented at, because all of these files are what we call hard links, and they point to data, right? And so the inode number is the representation of where the data actually lives that the hard link points to. And that's why hard links cannot go across partitions or across hard disks, and why symlinks can, right? Hard links cannot go across those things because the inodes are specific to the file system that they live on. So if you make another partition, then your inode number for a file could be the same as one on a different partition, for instance, because the numbers are per partition, right? So your hard links have to be on the same partition. And so what that means is that if I create a hard link, for instance, if I do an ln and I do test.text here, right? And then I do test.text again, but instead I'll do, what, test.link maybe? And I ls, you'll see I now have a test.link. And if I do that same command, ls tac li, you'll see that I have two files now that have the same inode number. And you'll also notice that this number here incremented. So that number is actually the number of hard links to this file. That's what that actually represents. Now, if I remove one of those two hard links, then the data is still going to be marked as in use, right, by the file system, because there's still a hard link pointing to it. If I remove both hard links, that will free the data up effectively. It'll still be there, but it'll be free. Now, you'll notice that nothing actually lives inside these files because I just touched them, so they're blank files. But if I echo something into one of them, right, just do this, doesn't matter, echo test into test.text, right, or .txt even. Okay, so if I now cat test.text, you can see that it outputs the test that I just echoed in there. But if I also cat test.link, it's also going to echo out that same value, and it's because those files are hard links. So now that you know what a hard link is, I'll tell you how to find them. So you can actually find them by inum. So if I do find and I do attack inum, like so, right? Then I can actually give it the hard link value. So if I didn't have these two files in the same directory, but there was a hard link like in another directory somewhere and I wanted to know where it was, I could copy this value here and I could paste it, and then it's going to return every single file recursively from the current directory down that shares that inode number. Of course, if I want to expand that search to the entire file system, I could do that by adding a / in there, right? But this is going to find all the files with that inode number. Now, interestingly, you can also add a prefix here. You can do a plus or a minus. And what that's going to do is it's going to find all files that have an inode number of less than the one that I put in there. And the plus obviously would do the opposite and find ones with a greater than number. Now, the other thing you can do is you can do same file, right? Like that. And then you can give it a file, test.txt. And that's good if you don't want to look up the inode number. So what that's going to do is it's going to basically allow you to put in a file name. So if you only know the file name and you don't want to be bothered to look up the inode number, then you can just say same file and then the file name, and it will output every single file that is the same file as that, effectively all the hard links to it. So now we can look at, and I'll show you why that's important later, because there are things that find can do additionally to clean up hard links. I haven't gotten to acting on what you're finding yet, but find is powerful and you can do that. So we'll get to that momentarily. I am going to go into that. But for the next thing we're going to do is we're going to take a look at file types of files. So obviously if we do find and we do type and then we give it an F, it's going to find all files recursively down that are of type file, okay? I could also do a D, and that's going to find everything that is technically a directory. Now what's cool about this is if you've ever run into a situation, say you're creating a SFTP share or some sort of shared directory or something where you want to manipulate the file permissions on the directory. Now, if you don't know how file permissions work with directories, you need the execute bit on directories. If you look at any directory, say the directory that I'm in, for instance, tag L and then dot, right? You're going to see that, that was not correct. You're going to see that the directory that I'm in is going to have that execute bit on it. Right? And the reason that is in order for a directory to be openable by a user, it has to be executable. Okay? If you take that execute bit away, the user is not going to be able to open the directory. What's important about that is if you want to recursively chmod a +X or execute privilege onto all directories, you're also going to recursively chmod that +X onto every file below that directory. And that, my friend, is a very bad move. You don't want to do that. And so what find gives you with this lovely command here is the ability to affect only the directories and not the files. So there's an extension to this where you can add an exec statement that will allow you to do things like chown all or chmod all the things that find finds. And it'll give you the ability to effectively change the permissions for just the directories recursively from a particular point in your file system on down. And that means that you could effectively set up an entire directory worth of file structures where only the directories are executable and everything underneath it will have sane file privileges without the execute bit being there. And that's great. That's exactly what you want. So that's very cool. You can also, of course, find symlinks, and as with the L in the front of the permissions here. So here we have D's. You'll notice that these are, kind of make sense, right? You have D for directory, and it was D to find directories here. It'll be L for symlinks. Now the dash is obviously different. The dash is a dash here. That just means normal file. And for the type here, it'll be an F. So that's an outlier. But everything else should basically follow the pattern. So if you want to find, for instance, all symlinks, you would type attack L, and it's going to give you all the symlinks under the directory that you're currently in. And that, of course, is, again, because I did not specify any particular path here, okay? I just omitted the path, and it's assuming the directory that I'm in, the current working directory, as it were. So now we can also do sockets. And so sockets would be an S if you wanted to find sockets. Now there's not going to be any sockets in my home directory, but if we do / we can find some sockets on the system. Let's do it with a sudo. You can find some sockets on the system. There's also let's see. There's also named pipes as well, and such. And basically sockets and named pipes are ways for applications to communicate with one another. In a sort of backend kind of way, I guess, which we can find as well. I'll get to that one. But the next one would be block devices. So we should cd into dev for this. This is where this will be the best. So if we want to find all the block devices, what are block devices? Block devices would be like your hard drives, CD-ROM drives, thumb drives, stuff like that. Those are block devices. So if I want to do a find, and then I want to do a tag type, right? And then I want to do a type of B. That's going to show me all the block devices. And you can see there SR0 would be the CD-ROM drive, which is virtual. And then, of course, you have VDA 5 to 1. Those are partitions. And then you have VDA, which is the actual device itself, which is the hard disk. The virtual hard disk is mounted to this VM. Okay, so that's block devices, and then you also have character devices, and this is where you're going to get things like your TTY terminals and all that stuff, your console, whatever. Anything that you can pass characters to. There's special devices, and I could probably make a video on some of that later on. There's some neat little tricks you could do with that, but that's for another time. And then, of course, there's named pipes, which if we do /, you can see some of those if I do a P. And I do a sudo, you can see some named pipes. So that's finding files of a particular type. Of course, I've showed you how to list file information. That's the next thing on my little cheat sheet here that I'm going by. But so we'll skip that. That's just adding the tag ls. You've seen that. So if I add a tag ls, you can see that we can list, the stuff here. And then the other thing we can do is we can find a file by its size. So if I go back to home here, I do an ls tag al. You can see we've got some stuff. Let's do a tag alh, actually, human readable. So we could find stuff, for instance, that is 807 megabytes, right? So, or just bytes, not even megabytes. So if we do ls, find, and then / or dash size, right? So what you can do is you can search for a very specific amount, right? So you can say I want to find something that has exactly 807 bytes. Now the way to specify bytes is the letter C. I know that's weird, but it is. Just go with me. And it'll find the file that has 807 bytes, which would be this guy here. Now, let's say you have a disk that's filling up and you want to find everything in that directory that has larger than X number of megabytes or something to it. You could do something like this, right? Plus 50 megabytes. And that'll find every file in here that has more than 50 megabytes. Now, there's nothing in here that's going to have more than 50 megabytes, but we can find kilobytes. So let's do that. Now we found everything under my home directory down that has more than 50 kilobytes. And it's a way where you can see what might be a good potential to clean up. Now, there are other ways to do that, like the du command would do that, for instance. There are other commands that can help you with finding storage issues with your system. But the find command it's just nice that you have that capability. You can find files that are big or really small or whatever and clean them up. Maybe if you want to find files that are blank, just a bunch, maybe somebody punched a whole bunch of files to the file system in order to test something and you want to go clean all that up. You could find every file that's blank on the file system and delete it. Stuff like that. So there's the letter B you can use for 512 byte blocks. You can use C for bytes. W is 2-word bytes or 2-byte words. I doubt anyone will be using those unless they're like a programmer or something. For us normies who don't really write a lot of code and they need to worry about stuff on that micro of a level, bytes, kilobytes, megabytes, and gigabytes probably what you want to worry about. Bytes is the only weird one with the letter C. Kilobytes is a lowercase k, megabytes is a capital M for some reason, and gigabytes is a capital G for some reason. And actually, I think technically it's gigabyte, mebibyte, and kibibyte, not kilobytes, megabytes, and gigabytes. Anyway, you can also find files by the time that they were created. So you can do things like find m time. And this is the time modified. And we can find files that were modified more than 30 minutes ago. We can find files that were modified less than 30 minutes ago. We can find files that were modified less than 1 minute ago. Maybe. Is that a minute ago? Or more than a minute ago? Yeah, something like that. Believe it or not, I did actually just push my ZSH setup to this thing, although I don't think it was more than a minute ago, so maybe I'm wrong about that. Oh, I'm sorry. Yes, I am wrong about that. These aren't minutes. This is days. So this is everything that was modified more than a day ago. This is everything that was modified less than a day ago. You can specify it down, I think, to the minute. Let's see. If we do min instead of m time. So if I wanted to find it down to the minute, it would be m min, right? And then I can do less than 1 minute ago, which would be my ZSH history. That makes perfect sense because I'm using the Z shell. And yeah, the history basically gets modified every time I type something in effectively. It's getting modified all the time, so that makes a lot of sense. But let's say I want to find something that was modified less than 30 minutes ago, right? That's all the files that have been modified less than 30 minutes ago, and that makes sense. It's a bunch of cache stuff, some stuff in local, basically all the stuff that generally, like logs and stuff that gets updated constantly. And then you have those files we played with earlier, or link file or text files. That was all made relatively recently. There are other ways, like there's ctime, which is the time that a file was changed. M is modified. Access time is like when it was touched last by a user. So you can find stuff by those. A time would be access time. C time would be change. And there are equivalents for the min one as well. So you have m min for days. A min is access time, and then C min is M min is similar to M time effectively. Basically, they all have their equivalents. I don't think I'm explaining this very well. M time is modified, right? So modified time is in days. But if you do M min, it's modified time in minutes. There's also A min, which is access time in minutes, and C min, which is creation time in minutes, or change time in minutes, or something to that effect. And then the other thing you can do with time is you can do newer. So if I do find tac newer, I can find a file that is newer than test.txt, for instance. .txt. There we go. And that's all the files that are newer or have been messed with, newer than test.txt. There's also a day start command, which changes the day start basically so that it's measured from the beginning of the day rather than 24 hours ago. By default, the times are all set so that the day starts 24 hours from the minute you type the command in. So I put the command in right now, so it's going to look 24 hours in the past, and that's what a day is. If you do attack day start, so find attack day start like that, and then do your m time command or whatever plus 1 day. What that's going to do is it's going to change it so that the day starts at exactly the beginning of the day for your time zone. In 24-hour blocks based on starting at midnight, basically, rather than based on whatever rather than being relevant to the or relative to the current time. The next thing we can talk about is negation. So if I wanted to find something that is not like something else, I can do that. So if I want to find all files in my home directory that do not have the name equal to star.txt, right? That's going to find, what did I do wrong? There. Yeah, so basically that'll find everything that does not have test.txt. And you should notice in here somewhere, I'm sure. Let's actually do this. So if I wanted to do iname star.txt, right? So that's going to find everything. Now this is obviously, there's an easier way to do this. I'm just doing this to demonstrate what these do, right? So this is going to find every file that has the .txt extension no matter what its case is, right? So it's going to find all files that have .txt in their file extension, but then I'm negating anything that has a lowercase .txt because I left off the I name here, right? It's just name. So basically anything that is all lowercase is going to be negated. And that's why we get just the one file back. So you can use that negation over and over and over again. So I could negate a path if I wanted to. You just got to prefix it with an exclamation point, right? And then you can do, I path, whatever you want in there. And then it'll find, stuff that does not have 3 dots in the path, So you can add as many negations as you want. Anding things together, basically, you can put a tac A in if you want, but you don't have to. And I should also mention that there are other ways to specify a not, so you can do tac not. The bang is probably the preferred way because it's POSIX compliant, but if you don't care about POSIX compliance, feel free to use the tac not. I think there's also a tac in as well. Tac A would be and, but if two things are next to each other, it's kind of assumed that the tac A is there, so you really don't need to put it in there unless you're very specifically, need it for some reason. There is also the concept of an or. So you can use a tac or, which is not POSIX compliant, or you can use tac O. So if I want to find something, like this, I could do that, which is going to or it. You can also add parentheses, but I think you have to backslash them. So if I wanted to, group two parts of it together, I think you have to escape it. I think it's maybe because it's hugging up on it like that. Yeah. So yeah, you can do an or situation and you can group things like that. So basically I'm saying if this thing has .txt in it and it does not have the name .txt in lowercase, or it doesn't have ... in it, and because no files are going to have ... in it, it's just going to return all of them, right? So like for instance, if I wanted to say or, it doesn't have the word crawl in it anywhere, right? CRAWL, right? So now you can see it's going to remove that crawl word from our results. You can see it was here and now it's not in this list, right? Because it was negated. So yeah, anyway, that is how you would do an or setup. Now, now to get to the fun stuff, and this is where it becomes dangerous, and this is where I have to put some disclaimers in. So let me clear the screen. Disclaimer, okay? Few warnings here. Number 1, always do your find with a bare command before issuing either of the 2 following commands. What do I mean by that, right? Do a find command with an I name, and then a .txt or whatever you want to find, right? And make sure you know what you're actually going to find, because otherwise you can destroy more than you intended to, okay? Make sure you know what find is going to output before you add on these following commands, because if you don't, you may accidentally delete, destroy, damage files you don't intend to destroy, okay? Another thing to understand about this is that the find command is evaluated as an expression, meaning that it's going to evaluate things from left to right in that order. And if you put things in, it's in that order of precedence. So the command I'm going to show you is tac delete, okay? So here's the thing, right? Right now, find is finding everything that has that text in it, right? Let's say I want to scope this to only stuff with that capital text in it, right? So now I want to negate, let's get rid of all this jazz here. I'm going to negate everything that has the lowercase text, right? And this is going to have just text.txt with a capital T, right? I want to delete just that file, okay? The proper way to do it would be to put delete here, okay? This is going to do what I want it to do. It's going to delete that file. Only that file, and that's what I want, right? If I am not careful and I put it here, it's going to delete everything that the first switch flag outputs. everything this outputs by itself, regardless of what this is doing, because it is evaluated as an expression from left to right. So my advice to you, especially until you know exactly what you are doing with the find command, is put your delete statement at the end, never in the middle, okay? Once you get good enough and you know what you're doing, you can experiment with putting delete in the middle if you want to do things like delete stuff here that are match this and then do more stuff with stuff that matches these things. If you want to get that complicated with it, you can. I would argue that you should never do that because it is highly dangerous and can be destructive to your system, okay? So don't do that. We're going to do this, okay? Now if we look and we ls this directory again, you'll notice that our text with a capital T is nowhere to be found because we have effectively deleted it. Think about this. If we pair this with, say, I want to delete all files that are blank, or all files in a directory that are over, 500 megabytes because I have huge logs and that are taking up all my storage and I want to make sure I clean them up so that we don't have that. You can do that. This makes it easy to do that. I have a whole bunch of old certificates that I want to remove from my system because I've got new ones coming in that I'm replacing them with, but I have a whole bunch of backups that some, person who didn't know how to clean up after themselves left behind. I can delete all the old stuff. I can use find whatever's older than 30 days, delete it. I can do that, and it's really not hard to do. It's easy. But again, if you're not careful, you can absolutely delete more than you intend. So please, please, please be very careful and know exactly what your find command is going to do before running it. All right? And that brings me to my next thing. And that is the exec command, right? And this is where find truly gets its power, right? So what is the exec command? You may have seen these constructs before. A lot of one-liners will be out there. Oh, just run this. And they don't really explain what it does or why. Oh, just run this. How do I recursively chmod a directory and only get the directories? That's the common one where I see this used. I'm going to explain it, okay? So if I wanted to recursively add the execute bit onto every directory below my home directory, I would do something like this, okay? Find all files with a type of v, right? And then I want to do tac exec, right? And again, left to right, okay? It is a expression, meaning if I put this exec in a different spot, it could do something that I don't intend. So I would tack this onto the end. Don't try to get creative, okay? So now what I can do is, I said we wanted to do a chmod. We'll do a +x, and then we'll do the brackets, and then we'll do a backslash, and then a semicolon. Okay. Now that probably looks very cryptic, especially if you're a new Linux user. You may recognize the chmod command. What this is effectively going to do is it's going to find all files below the current directory that I'm in, all directories effectively, all files that are directories, and it's going to add the execute privilege to those files. Now why is it going to do that? Let me break this down for you, okay? So you should probably already be well aware of what this is doing by now, because that's just the find all directories, right? That's fine. You should probably have an understanding of that. This is telling it to execute some command against what we found, okay? This is the command we're going to execute. It's a chmod. We're using this flag with that command, so we're going to add the execute privilege to whatever we find. This is a placeholder, right? This is a placeholder that says any file that is found goes here, right? So if I were going to use the chmod command normally without the find command, I would use it like this. I would do chmod +x and a path to whatever I want to add the +x to, right? This is basically taking all those stuff that gets found with the find command and using it as a path to what you're chmodding, right? And then the backslash semicolon is a special character. Really, the semicolon is what is important. The backslash is kind of... it's there to escape the semicolon, to make sure it gets interpreted as part of the find command and not as a shell argument or something, not as something. It's making sure that it gets interpreted correctly. It's basically the way I can put it in layman's terms. And there is actually another option you can use here. There's actually two of them. You can use a plus as well, and you don't need the backslash with a plus. And the difference is that the backslash semicolon is probably what you want, right? So if you do a backslash semicolon like that, what that's telling it to do is it's saying, run this like it's a loop, okay? So what I want you to do is I want you to find each file, and as you find them, I want you to put it in the chmod spot here, and I want you to just do it in a loop. One, then the next, then the next, then the next, then the next. If you do a plus, it kind of globs them together. So it basically says find all the stuff and then do something with it. And that's the difference. So 9 out of 10, you probably want backslash semicolon, right? Backslash semicolon, again, just says, it tells it to work in a loop and then execute one at a time and output one at a time the output, right? Now, I don't necessarily want to, I mean, it won't hurt anything to run this, but I don't necessarily want to do this. So instead, I'll show it to you like this. So that's going to ls all the directories that it found effectively, right? I can do a tag al if I want. And that's going to ls them in that way. Now, obviously, that's a bit silly because we have the tag ls, which actually, we have, you know, this, which effectively would do the same thing. So that's a bit silly to do it that way. But just to demonstrate in a non-destructive manner what the exec privilege does, or what the exec actually does there, that's what it does, okay? So that's how it works. And I think, is that all you needed to know? I want to say it is. Yeah, that's probably a good place to wind down here. So there is one other thing I probably want to show you just before we end the video, and that is if I do a find and then I do same file maybe, or the inum thing, you know. So this is going to find, again, run your command first. If I added a delete here, right, this is how I would clean up these two files. So if I want to delete all files that are the same as that one on this particular file system, I could use a command like that. And you'll notice now that my home directory is actually blank, well, except for the hidden files, obviously. But you can see my text files are very much gone. So that is a you know, kind of shotgun introduction to the find command. I hope that it changes your life for the better and that you all you know, get some great use out of it. Thank you guys for watching. I hope to make more videos soon. I do have a lot of ideas for some upcoming stuff if I get the time to work on it. We'll see how it goes. But yeah, I'll see you in the next video.